Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge. First question, count the number of consistent strings. Now the thing is that let us first read this question, then check the constraints for the same, that like what sort of possible solution could be there and what should be the time complexity and space complexity for the same. And then we'll check out for the possible solution, then implementation part with possible edge cases which are there, and then finally the time complexity and space complexity, and if it could be further optimized or not. So now here first let us read this question. So you are given a string allowed consisting of distinct characters and an array of string words. So now here this allowed string is given to us, and in this consists of all the distinct characters. Now a string is consistent if all the characters in the string appear in the string allowed. Now here this words vector of string which is given to us. Now when a string is consistent, as per the question, that if this is that allowed string which is there, so whatever characters which are present in that, those are present in that particular string. If that is not present and apart from that some other is present, then that is not allowed. So here B is present, but this is something apart from allowed, right? So that is not qualified for being a consistent string. This is present, this is present, this is present, this is present, so it is qualified. This is present, this is present, this qualified. This is present, this is present, this is present, this is present, but this is not present, right? So that's why this is not qualified. Now in the second example, ABC, A is present, thus qualified. B is present, qualified. C present, qualified. AB present, AC present, BC present, ABC present. So all these strings are qualified, and that's why answer is 7. And in this CAD which is there, so C is present, ABCD is present, B is present, BA is present, BAC is present, BAD is present, BAC, wait, no, BAC is not present because it was D. This is also not present, this is also not present. AC is present and D is present, so that's why all those which are present, so that is allowed as the then 4 becomes the answer. Now the crux of this question is, means from the question which is given to us, that if a particular character which is present in the allowed, if that comes into picture in the vector of string A, B or AB itself or BA, one minute. AB, BA or AAB, or like basically any number of time that particular character is present, but that character is present, right? So that would be qualified. But if there is some other character which is appended to the same, which is not present in allowed, then that particular string won't qualify to be consistent string, and that we are not required to be counted as our answer. So that is the thing here. Now here this was the crux of this question, but now comes the part for going ahead with the implementation part. Let us go ahead and check the constraints. So here if you see the words dot length, this words dot length this words dot length which is there, that is 10 raised to power 4, right? So that means up to 10 raised to power 4 strings would be present in that words. Now allowed length is up to 26, that means up to all the characters of alphabet, means A, B, C which is there, those could be used. Words of I dot length is up to 10, even if they are duplicated as well, still the length will be at max till 10. Now character in allowed are distinct, that is mentioned in the question itself, and word of I in allowed contains only lowercase English letters. So basically there are no upper cases in the basically the allowed and words input which is given to us. So that's why we are not required to, means now the things become easy, that we are not required to handle the h case of uppercase, then we would have been required to write that much portion of code as well. So that's the thing. Now I hope everyone is clear with the question. Now comes the part that what are the possible solutions. So as per this question, if you see what you can detect, the thing is here what we are required to do is we need to check if these characters are present in these strings. So basically, as we are required to do a lookup sort of thing, right? That are these characters present in that words also or not, right? So that's why in that context, what we can do is that we can use some sort of storage and then check are those characters present in the words a vector of string which is given to us or not. Means basically some sort of storage which we can check that yeah, these characters are there, and we can do a easy lookup thing. Means basically this ab which is given to us, right? So we can easily check that if this particular ab which is given to us, so whatever characters are there, so are these here or not? Means we can easily check that. So in that context, for an easy lookup, we can easily use a hash set here. So that becomes a question of hashing here. And apart from hashing, we can easily go ahead with bit manipulation as well, because anyhow we can easily check that if this particular bit is present or not. Means basically using the masking method and so on. So we can use bit manipulation as well, and so that we can go ahead and check if that bit is set and not, and so on. That is one of the possible method. Let me write it. So the possible solutions are, first one is the hashing which is there, and the second possible solution is via bit manipulation, and the third possible solution which could be there. These all solution which I am telling, these are not brute force solutions. Anyhow, the brute force solution in the same would be like you just naively go ahead and check that if this particular is there in loud or not, if it is there in allowed or not, like that. That would be a complete naive method. But when I was reading this question, this hashing came to my mind at the first, just because of the lookup which we are required to do. And anyhow, in interviews as well, we have less time and we need to just tell the solution, the possible solution, that yeah, these are the possible solution, and we if you allow me, I can code this particular solution. That is the thing. So now this bit manipulation could also be used. And now the third which is there, that is like we can optimize the space which is being used, because here anyhow it would be 26 only, right? So in context to that, after optimization of space, that solution could also be possible. But before going ahead with all these possible solution, let us just focus on the first one which is there, the hashing one, because that is one of the most easiest which comes to mind when we are solving the questions. So now, before going ahead with the implementation part, let us think of some of the edge cases which could be possible, right? So here the edge cases which could be possible, see, anyhow uppercase is already handled by constraint, right? Now about the edge cases, so if we see here, like if we write a solution, because anyhow the allowed which is there, we will be using a map here, means basically an unordered set, not map. We are not required to have a anything for sorting, so we will be using unordered set here, right? So anyhow these characters would be inside this unordered set, fine. But now comes the part that we will be doing lookup for the same, then we will be matching a and d, right? for easily we can just stop at that particular point for reducing the time. What are the what thing which we can do is, we can, rather than going ahead that this is present, this is present, this is present, we can go ahead with the fact that this is not present. I mean, like that other way around we can code our thing, so that will reduce the time as well. But anyhow, that doesn't becomes an edge case, just that is a sort of optimization I'm trying to tell. Now apart from that, if we see, like anyhow minimum we are required, right? So that we can easily go ahead with the lookup part. But the only thing which we need to check is that which is not present, and then we need to do a easy escape from that particular, that would be the thing. Apart from that, I'm not sure about any edge case which I can find in this. But yeah, the way we are handling it, it will be like completely done sort of. And the time complexity and space complexity of this hashing solution which would be, so now see, first thing would be um, 1 minute, I'm trying to just scroll it up. Yeah, so now the time complexity and space complexity. So the time complexity, the first thing would be for this particular, the unordered set which we would be using, so filling up that unordered set, right? So that will be having some time complexity, right? Anyhow filling up won't take, it will just take that much time, the maximum characters which are there. So maximum character which are there are up to 26, right? So anyhow if we consider that 26 as the constant number, right? So here the space complexity will become order of 1, and time complexity here is anyhow dependent on this 26, and all are already unique, right? So in that context we can say it as order of 1, but we don't know that, like there could be how many characters will, it could be like 2 3 4, like that. It will be always a variable sort of only. So here, as dependent on this, we can easily go ahead and say that it is order of n m, because we are filling this up. And the second time complexity which will come into picture is when we are doing checking these words which are there. So word into their length. So let us say the word into their length means total number of words which are there are into their length, and at max let us say some k which is there, right? And words which are there into k characters which are there. So these are the thing, and anyhow these would be separated, not inside means looped inside something. So it will ultimately become m plus n into k. So that would be the time complexity, and the space complexity is anyhow order of 1. So that would be the thing here. So now let us go ahead with the coding part for the same. So now the first thing which is there is about checking for this allowed characters which are there, checking and putting them in some easy to look up storage. So for that we have used the unordered set, initialized and declared basically our answer with 0, and then for char I in allowed we are inserting that into our allowed set, so that anyhow becomes order of k time complexity the way we have earlier discussed. And the space complexity anyhow it would be 26 characters only, right? So that's why it would be order of 1. Now here the next part and the final part and the main part of this is that here we are basically extracting all the words which are there in our words, and each word is basically a string, right? So that's why string of word in words, and then counter is not required. We are keeping a flag as well for this fact that if we are not able to find that. Okay, let us just skip that flag part. We will just go with the flow. Now here we are having we are checking each word, and then we are checking each character of that word, right? So here we are checking that if not allowed, set dot count I means if that particular character is not present in the allowed word which is given to us as the input, then we will be breaking out of this particular inner loop which is there. Okay, fine. But now comes the part that if it breaks out, and at that point we just have initialized, if it breaks out, fine, and we have to increase our answers, right? But if it doesn't breaks out, then also we know that we need to initialize our answer. Means not initialize, basically increase our answer, right? So at that point we won't be able to know that if it break out from that loop, that's why it came at that particular point, or it was just with the flow that we got the answer and that's why it came to there, right? So for this purpose only, we are here initializing one flag with the true at the start, means whenever it enters here it will be always initialized with true. And then if that particular word which is there, it has some character which is not there in allowed word, right? So then we will be setting a flag to false, and here it will check if that particular flag is not false, then only it will increment the answer. That is the thing, and that's why we are using this flag. And basically this is, while doing the code, this is one of the possible edge, can't say is at the edge case, but it's like that it is required in this logic, else your logic won't work without this flag. That is the thing. Or you would be required to think of some other way around which could help you. And now at the end we'll just return our answer. So here from the code itself, I hope now it is clear that what is the time complexity. That is k plus n into m. Here although I have changed, here n into m refers to m the number of words and n the size of the maximum size of the word with the maximum length. And the time complexity is this, and the space complexity that comes out to be order of 26, because we are using this only this one as the space, right? And it marks the character which could reside into the same at 26, so that's why here it becomes order of 1 as the space complexity. So this was about today's question. If you have any doubt, you could comment it down, and yeah, feel free to paste your answers as well in the comment, and make sure to subscribe my channel and share among your friends if you really like the solution, and if any suggestion, that also you can comment down. Thank you.